everyone, in this video I'm going to go over your review sheet for your test. This one is review sheet number 2, quarter 4. Test is Thursday for periods 1 and 2, and Friday for period 3, 4, and 7 to 8. Alright, so the first question says, which of the following situations qualifies as an observational study? Now remember, observational means you cannot interfere. So the first thing says, the girls at your high school are surveyed to determine if they believe there is a sexual stereotype in the school newspaper. This looks like it's a survey asking questions. So I wouldn't classify this as a straightforward observational study. We do say sometimes that observational studies can be surveys. But let's see what else the options are for us. The next one says 2 flower pots are planted with the same type of seed. One is given 0.2 cups of water while the other is given 0.5 cups of water each day. At the end of the month, the growth of each plant is observed and measured. Now they're trying to trick you here using the word observed, but this is probably an experiment because we're giving a treatment to something and we are testing an analysis. The next one says a team of researchers records the number of types of cars that pass a specific intersection. There is no interference here. They're just watching cars pass by and recording the numbers. So I'm kind of going with this one right here as my answer. A student flips a coin 100 times and records the number of heads. That looks like interference. So I'm going to go with this one right here. The best sampling method for obtaining a random sample, keyword random sample, of people who represent the entire population of a town. Now think about a town. You got to make sure you have everyone represented. So the first one says selecting every third person entering the library. Does everyone go to the library? No. So I'm not going to choose that one. Selecting every other person entering the school building. Not everyone's going to go to the school building. We're going to avoid all the people who don't work in a school building and all the all the people who don't go to school or all the people who are not in a school building, so we're going to not choose that one. The first 30 people entering a gas station is pretty good, but it's the first 30, so not random enough. And the next one says selecting every 5th person at the grocery store. This is probably the best because everyone needs to get food, and it's pretty random selecting every 5th person. Which of the following methods should a researcher use to study the effects of a new drug as a treatment for cancer? I would say experiment for this one because you're trying to see if the new treatment works, and you're looking for a response. The next question says, which statement about a statistical study is true? Choice 1 says, a survey of all English classes in a high school would be a good sample to determine the number of hours students throughout the school spend studying. This is a pretty okay answer, so I'm gonna star this one because I think that's a good one because everyone takes English, and you could get a good representative sample with that. The next question says, the survey of 9th graders in a high school would be a good sample to determine the number of students' parking spaces needed at the high school. This isn't good. It's 9th graders. They don't park, so why would I care? A survey of all students in one lunch period at a high school would be a good sample to determine the number of hours adults spend on social media. First off, this is one lunch period, not enough representation. And also, we're talking about adults, so why would that even be asked of a student? The next one says a survey of all calculus students in a high school would be a good sample to determine the number of students throughout the school who don't like math. All calculus students is okay, but if you think about it, getting up to the calculus level, not every student gets up to that level, and also you're asking calculus students who don't like math. If you're up to that level, you most likely like math, so I'm going to go with choice 1 only. Next section. We got another quadratic formula problem. I think this is the same one from the last review sheet. I'm so sorry. It's not the same question on the test, but there is quadratic formula on your final, so I wanted to make sure it was on here, and then I didn't realize I picked the same one, but okay, no problem. So I know this is quadratic formula. Looking at the choices, I can see the plus or minuses in choices 3 or 4. I'm actually going to probably go with those. And then I'm going to plug into the quadratic formula. So x equals negative b, negative 2, plus or minus the square root of b squared. So 2 squared minus 4, a is 3 and c is 7, all over 2 times 3, which is a. This is going to be over 6, negative 2 stays. The square root on the inside becomes negative 80. This breaks up into negative 16 and 5, which is 4i rad 5. And then I have to share the love, break up the heart, so I got negative 2 over 6 plus or minus 4i radical 5 over 6. And when you reduce that, that gets you negative 1/3, and this is the only choice with an I, so. Next one says, what is the transformation that was applied to the graph of g of x equals 4 to the x? And then this is 4x plus 2 minus 3. So I see there's an x plus 2 and a minus 3. Just zooming in here so you guys can really see it. I used to tell you guys that inside the parentheses means left or right, and outside the parentheses means up or down. The parentheses you don't really see here, so that's why I'm putting them in now, and they're not going to show them, but they are always the exponent. So this is your left 2 movement, and this is your down 3 movement. Now, if you don't believe me, you can always graph the parent function 4 to the x, and then graph this one and see how, you can look at the y-intercept, how that moves. That would be a good thing to look at. Okay, so this one wants you to graph a log equation on the set of axes below, and then state the domain and the range and the equation of the asymptote. So we want to make sure we state our domain. We want to make sure we state our asymptote. We could actually find the domain and asymptote without even graphing it. It always has to do with the inside of the parentheses. If you set that equal to 0 and subtract 2, that actually gives you the asymptote. And then we always want this to be greater than 0, so I believe this would be the domain, because you don't want the inside of the log to be negative. But we can graph and see the actual picture here and see the domain that way also. So the first thing I would do is I would find the asymptote like I did before, and I would then plot it on the grid. And then I would go to my calculator, hit math, and go up and do log base and make sure I have log 3, x plus 2 minus 4, and then I would plot points. I have a few of them plotted here. -1, 1, 2, 3, 4. So -1, -4, 1, 2, 3, 4. That's one of them. And then 0, -3, I think is another one. And then what's this other one I have plotted? 1, 2, 3, 4, 5, 6, 7. 7, -2. 1, 2, 3, 4, 5, 6, 7, -2. Very important that you have the right points that are solid. You put an arrow all the way at the end, and you put another arrow all the way down here, not touching the asymptote. And you guys can see that it is greater than -2, and the asymptote is -2. They're saying here a parabola has a focus of 1, 2, and a directrix of -2. I would plot my focus first. Remember, this is what the parabola hugs. And then they're saying -2 going through y is your directrix. That means your vertex is happily halfway between these guys. These are 4 apart, so that means that it's happily halfway at 2 and 2, and it opens up. Now, they have the choices in y equals form, which kind of stinks, but we have the formula given to us. I'm going to use the positive version, so positive 4a, and I'm going to plug in. So my vertex is 1, 0, and my a value is 2. So I'm going to do x minus 1 squared equals 4 times 1, and then y minus 0. Because remember, your vertex goes in the spot of h and k. And then simplify. So we got x minus 1 squared. I don't know why I made a 1 when I clearly said it was 2. That's 8, and that's just y. Now getting the y alone, we divide by 8, and you can see that this is 1/8 x minus 1 squared equals y. They pulled the 1/8 because there's a 1 there and then it comes to the front. So my answer choice is choice 4. Okay, next page. A lot going on here. This one wants you to write an exponential regression equation. Make sure you round properly. They want you to round to the nearest thousandth, so 3 places. Exponential regression is y equals ab to the x. Make sure you have y equals and to the x here so that you get full credit. You're going to put this into L1 and L2. You're going to press stat, edit, enter the list L1, L2. You can just enter with division signs for the fractions. And then you're going to go to stat, calc, and pick exponential regression. And you're going to find the a value to be 1.223. And then the b value to be 2.652. No, it's 2.652. Okay. Next question says, A medical researcher is interested in testing a new medicine for migraine headaches. She decides to conduct a clinical trial on 100 randomly selected adults, which is great. She tells you they are randomly selected, who get migraine headaches at a rate of 1 per week. Describe how she can conduct a controlled experiment to examine the effect of the new medicine on the migraine effects. Well, kudos to her. She has random selection already set into place, which is nice to have in an experiment. Remember, it's not necessary, but we definitely need one thing to happen after random selection. She needs to randomly assign, she needs to first randomly, you could write this in sentences and bullet points, I don't really care. Steps, I'm doing one. Randomly assign her participants into, I don't know what's going on upstairs. I'm babysitting dogs, so hopefully they're fine. Into groups of 50. And randomly assign into groups of 50. And then I'm going to have to check what's going on upstairs. Hold on. False alarm, everyone. It was just a squirrel that they were barking at, but it was really loud, so making sure that everyone's fine. Okay, where were we? We were talking about this experiment, and we first randomly selected, which was good. She needs to first randomly assign her participants into groups of 50. And I should say one group would get the medicine. I know my handwriting's not the best on this. And the other, you could either say would get a placebo, or you could even say or a standard painkiller or migraine medicine. I should specify over here would get the new, I'll write that in a different color, new medicine. And then step 3, so what do we have? We have random assignment, we have a control group, we already have enough people, and she would then be able to conclude cause and effect, or analyze her study for cause and effect. Alright, next question says, the school wants to talk to students and for a proposed cell phone policy. The students in the school are numbered from 1 to 750. Use a list of random digits below to identify the sample of 10 students for the school to talk to. Now the first thing you're going to want to do is you're going to want to state that 001 is your first student. So you're going to say 001 is student number 1. And then 750 is the last student. That's the first thing I would state. And actually this probably would go into the explanation. I would say, I would first make 001 my first student and 750 my last. Now, if this was a 2-digit situation, you would do 01. So like say 75 was the last student number, you would do 01. Okay, so that's the first thing you would do. And now you're going to start. So they say, then I start at the beginning and go by 3s, ignoring, in this case, numbers over 750 and repeats, because you don't want to ask the same student. So let's see our first number. Our first number is 619. 619's in range, so I'm going to keep that one. Next one's 543. That one's also in range. The next one's 891. That's bigger than 750, so I'm not going to use that one. Keep going by 3s though, guys, okay? So 684, still in range, so I'm going to keep that one. 532, going to keep that one. 176, going to keep that one. 601, keeping that one because these guys are still in range. 233, we're good with that one. 022, also go with him. And then we get to 684, and I'm like, oh, well, that's in range, but we already have 684 right here, so I do not want to use him again. Okay, so 135 would be good. 332, that's good. I don't even know how many I have. Do I have enough? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And then just list them. So we got 619, 543, 684, 532, 176, 601, 233, 022, 135, and 332. Make sure you have all 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because whenever I give this question on any other test, like any other year, people forget all of the numbers. Okay, a researcher randomly divides 50 bean plants into two groups. He puts one group by the window to receive natural light and the second group under an artificial light. He records the growth of the plants. Which data collection is described in the situation? This is a controlled experiment because he has two groups, one getting a light and another one getting artificial light. He's recording growth, which is the response. He randomly divides them, so this sounds good. Sounds like an experiment to me. Pretty good one, too. The operator of the local mall wants to find out how many of the mall's employees make purchases in the food court when they are working. She hopes to use these data to increase the rent and attract new food vendors. In total, there are 1,023 employees who work at the mall. The best method to obtain a random sample of the employees would be to survey all 170 employees at each of the larger stores, which is only the larger one, not the smaller one, so I'm not really liking that. All 50% of the 90 employees at the food court, which is not everyone, and that's not even, I'm not really liking that. Every employee. We want a sample, not a census. And then every 30th employee entering each mall entrance for 1 week. This one looks like the best because it's random. It's every 30th employee. The key word here is they wanted a random sample, so I would go with that. Is this the last page, please? Yep, nice. Okay. Okie dokie. Cheap Fast Gas is conducting a consumer satisfaction survey. Which method would most likely lead to a biased sample? Interviewing every 5th customer to come in the station. That one's good. We like that. That's like random. Interviewing customers chosen at random. That says random. Interviewing customers who call an 800 number posted on a customer's receipt. This one here is most likely the one we're going to pick because a number posted on a customer's receipt, the people who are going to call that are not going to call unless they have a problem with the gas station. Mostly people don't call for good things unless they want to support the gas station for some reason. Interviewing every customer who comes into the station in a day of the week chosen at random out of a hat. That's pretty good. That's not going to lead to bias, so we like that one. All right, what is the solution set of this guy? So we're going to solve. We're going to square both sides, and then you're going to get x squared plus 6x plus 9. Now I got that because I did box method or FOIL in my head, whatever floats your boat, so it didn't come out of nowhere. Then I'm going to subtract this and make this equal to 0. And I get x squared minus 6x plus 8 equals 0. And then I'm going to do x. Factors of 8 that add to 6 are 4 and 2. I just realized this has to be a minus because we want a negative 6. And I get my two answers because I'm setting these both equal to 0. And I get x equals 4 and x equals 2. And you want to check your answers and these both work. Make sure you check. Okay, a recursive formula for this sequence. This is not recursive. This is not recursive. Recursive has to have two parts. Then you got to figure out, is this going down by 10 every term, or is it just multiplying by 3/4? It's definitely not going down by 10 for every term because that's not 20, so I'm not going to choose that one. This must be my answer. And you can check by doing 40 times 3/4 and 30 times 3/4 and seeing if you get the numbers. Which expression is equivalent to this guy? Now what's nice is this is multiple choice, so technically you could plug this whole thing in and then plug all in the choices and see if they equal. I think that would work, but otherwise it's just box method because there's a squared there. So I'm going to do 9k squared minus 6ki, so minus 6ki, and then 4i squared. And I'll combine like terms. This is 12ki negative, and then this, remember, that's negative 1, I squared. So that makes this all negative 4, and then that gives me choice 3. Yep. Determine a procedure to see if this is a factor of this function. So I'm going to use synthetic division, but you could plug 5 into x and see if it equals 0, but synthetic division would work. 2, multiply 10, add 6, multiply 30, add 23, multiply 115. I don't know why I have a 0 there. And then that gets you to 105. This is not a factor because we have a remainder of 105. So not a factor because the remainder is 105, not 0. You could also plug in and use that other trick. Last question is a circle and a line. We're going to do substitution by plugging this into here. Squared. And then you're going to have to do box method here, or FOIL. Minus 30. I'll get 9x squared minus 90x minus 90x plus 900, and then I have x squared over here, so I'm going to keep that. And then I have 9x squared minus 180x plus 900. Don't forget this is equal to 100. Combining like terms, these guys combine to 10x squared. And then I'm going to make this equal to 0 to solve. Now, it would make my life easier if you divide by 10 all across the board, and then it gets rid of it. And then factors of 80 that add to 18 are just 10 and 8. Make these both equal to 0, and we get x equals 10, and x equals 8. Now remember, these are just your x values. You need to find the y values to get this completely correct. I'm going to use the equation y equals 3x minus 30 from the beginning to get these values. So 3 times 10 minus 30, that's 30 minus 30, that's 0. And then I'll do it again with 3 times 8 minus 30, and that's 3 times 8 is 24 minus 30, so that gets me a negative 6, and that's that. And this is your review sheet. I hope you study, and good luck, and I will see you around, friends.